And welcome to 4.4b, the homework video edition. Alright, so let's get started here. They want us to factor this expression. So we're going to go in order, check the first thing, which would be the order of this. It's in the correct order. You have the squared term, then the single term meaning x to the 1, and then the constant. So the order is good. Now we have to check to see if there's a greatest common factor or a leading coefficient of a negative. There's no greatest common factor, but there is a leading coefficient that's negative. So what I'm going to do is I'm going to factor out the negative first. So if I factor out the negative, this is what I'm going to have. Then I'm going to check to see if it's special at all, meaning is it a difference of two squares or a perfect square trinomial. I'm not checking this, I'm checking this here. So the answer is no, there's nothing really special about that. It's just a regular run-of-the-mill trinomial. So what we're going to do is we're just going to go straight to factoring this. So it's an easy trinomial, meaning the lead coefficient is 1. So to get the x squared, I'm going to have x and x. I need two numbers that multiply to give me negative 20, but add up to a positive 1. So it's going to be positive 5 and negative 4. And that's your answer. This one over here, first let's check the order. The order is good. X squared, x, constant. Check to see if there's a GCF or a negative in the lead coefficient. There's none, so that's good. Let's check if it's special in any way. Well, we're all special in a way, but this is not special in that it's not a perfect square difference, and it's not a perfect square trinomial. So that's taken care of. So let's just factor this. Now this is a hard trinomial because the lead coefficient is larger than 1. So let's do the box method here. So let's put in the first term here, the last term here. My AC is 7 times 12, which is 84. So let's write down all of the possible factors of 84. So we're going to have 1 times 84, 2 times 42, 3 times 28, 4 times 21, 6 times 14, 7 times 12. Man, could they pick a better number? It's crazy. 8 doesn't go in, 9, 10, 11, that's about it right there. So now let's read the signs. The negative here tells us that the signs are going to be different. The larger number is going to be negative, so these are our negatives. That makes these our positives. They're made up of x's, so let's put the x's in these. And then we ask ourselves, which one of these combinations adds to a negative 8x? This would be negative 5. This is negative 8. This is the right one. So let's put the 6x here, the negative 14x here. This negative makes that negative. That's positive, that's positive, 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 positive. Let's factor out. The largest number between the 12 and 14 is a 2. The most we can take out here is an x. Over here we have 7x. And over here we have 6. So our final factored Answer is 7x plus 6 times x minus 2. And you can always check your answer on these problems by foiling this out and making sure you get the original problem. Number 3, how's the order? The order is good. Is there a greatest common factor, and is the first term negative? No greatest common factor. First term is not negative. We're good for that. Is it special? The first thing that we want to check for is the ends, or are the ends perfect squares? Yes. So there's a chance that this might be a perfect square trinomial. So the square root of x squared is x. The square root of 49 is 7. If I multiply those and double it, do I get the 14x? Yes. So it is a perfect square trinomial. So you put one set of parentheses with a squared, you drop the x in, the 7 in, and this sign. And that's it, x minus 7 squared. Number 4, the order is good. Greatest common factor, lead coefficient of being a negative. Lead coefficient is negative, so I got to take care of that. So let's factor out the negative first. Is it special? Well, this is a perfect square, and that's a perfect square. That's 2, if you take the square root, and that's x. If I multiply those, I get 2x, and if I double it, I get 4x, not 5x. So it's not special. But what we can do is we can factor it using trial and error, since it's an easy trinomial. So x and x. Same sign, both negative. Multiply to give you 4, add to give you 5. So 4 and 1, and that's your answer. And number 5. Let's check the order. The order is good. GCF, or a leading coefficient, being negative. There's nothing. That's good. Check to see if it's special. Let's write it down here. The ends are perfect squares, so this might mean that it's special. The square root of this is 5y. 12 squared is 144. If I multiply those together, I get 60y, and if I double it, I get 120y. So it is special. So what I'm going to have is one set of parentheses squared. 5y goes here. 12 goes here. And this sign goes in the middle. And you're done. Number 6. This is a temporary substitution problem. So what we're going to do is we're going to let k equal x plus 5 just for a minute. 6k squared minus 5k plus 1. So again, we're exchanging x plus 5 and we're putting k in place of it. So this is a hard trinomial, so we're going to use the box method. Man, that is a horrible box. Good gravy. Alright. Still not that great, but we'll just make do with it. Alright, so 6k squared, the lead goes there. The constant goes there. AC is 6 times 1, which is 6. Let's write down our possibilities. 1 and 6, 2 and 3. They're made up of k's, so we'll put little k's here. Same sign, both are negative. So negative for everybody. Which combination adds to a negative 5k? That would be this one here. So let's drop the negative 2k and the negative 3k. This negative makes that negative, that positive, 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 negative, negative. Factor, that's a 1. Factor 2x. Factor 3, sorry, I said 2k, not 2x. Actually, I said 2x, but it should be 2k. So 3k and 1 here. So 3k minus 1 times 2k minus 1. But before I move on, I remember that I replaced k, or I replaced x plus 5 with k. Now I have to replace k with x plus 5. So I'm going to use parentheses, because whenever you substitute, use parentheses. So I'm replacing x plus 5 in for k here and here. So at this point, 3 times x is 3x. 3 times 5 is 15. 2 times x is 2x. 2 times 5 is 10 minus 1. And 3x plus 15 minus 1 is 3x plus 14. 2x plus 10 minus 1 is 2x plus 9. And that's your final answer. Okay, so 7. Before we identify all this stuff, all that stuff is a result, most of it at least, is a result of the vertex. So let's find the vertex first. This is -3, comma, -1. Take the opposite of this because it's hanging out by the x. Over here, you're seeing k for what it is. It's not hanging out by the y over here, so it's -1. So -3, -1. So the axis of symmetry is going to be x equals -3. It is opening up because a is positive. So if it opens up, that means it's going to have a min value. That value is going to be -1. The domain is all reals. The range, since it opens up, is going to be the set of all y's such that y is greater than or equal to the min value. And that's done. Number 8. That looks like I'm going to need a calculator. So let me get that out. Let's move it over here. Let me just move the problem over so I can move this over here. Alright. Turn the calculator on. Go to Stat, Edit. It's all cleared out. So we're finding a quadratic model. So we're going to enter the x values in. So 0.5, 0.75, 1, and 1.25. Input the outputs for L2. So 10, 10.5, 9, and 5.5. So go to Stat, Calc 5, go down to Calculate. So you get A being -16, B being 22, and C being 3. So A was -16, B 22, C 3. So the model will be f of x equals -16x squared plus 22x plus 3. Number 9, rewrite the equation in vertex form. So it would be helpful to know the vertex. So the opposite of b divided by 2 times a. That becomes 2 divided by -2, which is -1. Let's plug in -1 back in. So y equals negative. -1 squared is 1. -2 times -1 is 2. 6 minus 1 is 5. So we have our vertex of -1, 5. So we know that. And it's asking us for the axis of symmetry. If you ever start a band, like a heavy metal band, name it axis of symmetry. I don't know why I said that, but do it. You'll be awesome one day. X equals -1. Okie dokie, number 10. Explain in words how to recognize whether a trinomial is a perfect square trinomial. So remember, a perfect square trinomial is a result of a binomial multiplied by itself, whether it's a plus b times a plus b or a minus b times a minus b, either one. When you multiply these out, you get a squared plus 2ab plus b squared, or you get, in this case, a squared minus 2ab plus b squared. So to recognize if a trinomial is a perfect square trinomial, what you have to do is you have to see if 2 times the product of the square roots of the ends, so 2 times the product of the square roots of the ends equals the middle term, then it is a perfect square trinomial, regardless if the middle term is positive or negative. So you could also describe it as if the product of the ends, meaning if you multiply, the product of the square roots of the ends doubled equals the middle term, then it is a perfect square trinomial. And that's it.